So we have seen that Git is a map where the keys are hashes and the values are pieces of content. But I also said that Git is not just a map, it's a persistent map. Where does persistence come from? Let's go back to the git hash object command we used a few minutes ago. If I want the apple pie content to be persistent, I can add the -w argument to this command. -w stands for write. So now, besides generating the hash, Git will also save this piece of content in its repository. However, now we don't have a repository yet, so if I try this command straight away, Git complains. We're not in a Git project. We don't have a repository. I don't know where to save the content. So let's turn this directory into a Git project. There is a command for that, and you probably used it already. It's a high-level porcelain command, git init. There. So we created a new repository, and Git is saying, look, the new empty repository is in this directory .git. That's a hidden directory. On this operating system, I can visualize hidden directories with the -a switch. So now Git has the .git directory, a place to save stuff, and if you run the hash object command again with -w, we get the hash and we also save the content. Let's see where exactly. Let's peek inside the .git directory. There are a few files and folders here, but for now, just look at this directory here, objects. This is called the object database. It's the place where Git saves all its objects, like the string apple pie we just saved. Let's peek inside. Ignore these two, the info and pack subdirectories for now, we'll come to these later. Instead, look at this subdirectory here. Its name is 23. And these are the first two hexadecimal digits of the hash of the content we just saved. And if we look inside 23, there is a file in here, and the name of this file is the remaining digits of the hash. Git uses this scheme to organize content and spread it over multiple directories. It's just a trick to avoid piling up all the content into a single, huge clutter directory. Our original string, apple pie, is inside this file. This is what Git calls a blob of data. A blob is a generic piece of content. However, the original string has been mangled a bit inside the file. Git added a small header and compressed the content to save space, so we cannot just open the file and read it. But we can use another low-level plumbing command to look at the content. It's called git cat file. Once again, don't worry if you don't remember this command, it's rarely used. I'm using it now just because I want to show you how Git saves content. Git cat file takes the hash of an object and an argument. If we run it with the -t argument, it stands for type, Git tells us what this piece of content is. It's a blob. And if we run it again with -p for pretty printing, then Git unzips the object, removes the header, and it prints out the actual content of the blob. And here it is, the string apple pie there. So far we have seen that Git can take any piece of content, generates the key for it, a shown hash, and then persists the content into the repository as a blob. A persistent map. This is the very basic of the Git model. Let's build on this and move on to the next layer of the onion.